For decades, healthy eating has been defined largely in terms of calories in versus calories out, with advice centered around portion control, food pyramids, and generalized nutrient ratios. While such guidelines may have once served a purpose in curbing overt malnutrition and promoting weight stability, they fall short when applied to the complex biological needs of aging individuals. Aging is not merely about maintaining body weight, it's about preserving function, resilience, and cellular integrity over time. This shift demands a fundamental reevaluation of what healthy eating truly means. Emerging insights from aging biology and nutritional science point toward a more sophisticated model, one that places autophagy, hormonal regulation, and micronutrient sufficiency at the center of dietary planning. Rather than counting calories, this approach advocates for nourishing cells with what they need to repair, adapt, and survive in a metabolically efficient and inflammation-resistant state. One of the key revelations in longevity science is the importance of autophagy, the body's internal recycling and cleanup system. As we age, autophagy declines, leading to the accumulation of damaged proteins, dysfunctional mitochondria, and cellular debris that impair metabolic performance and drive chronic inflammation. Traditional diet advice often overlooks this process entirely. By contrast, a more advanced nutritional framework would prioritize the timing and composition of food to stimulate autophagy in a controlled and sustainable way. This includes not just reducing overall caloric intake, but more strategically manipulating macronutrients, especially carbohydrates and protein, to avoid overstimulation of mTOR and insulin while activating EMPK and sirtuins. Intermittent fasting, time-restricted feeding, and moderate carbohydrate restriction are all tools that can be used to cycle the body in and out of autophagic states, providing cellular housekeeping without triggering malnutrition. Equally critical is the role of hormonal regulation in aging. Blood sugar stability, insulin sensitivity, cortisol rhythm, and thyroid function all change with age, and they are deeply influenced by dietary inputs. High glycemic diets and ultra-processed foods disrupt insulin and leptin signaling, promoting fat gain and metabolic inflexibility even in individuals who are not overeating. Conversely, diets rich in fiber, healthy fats, and phytonutrients help stabilize blood sugar, regulate hunger, and support thyroid and adrenal health. This is especially important as older adults become more prone to insulin resistance and sarcopenia, both of which accelerate the aging process. Nutritional plans should therefore focus not just on preventing excess calories, but on minimizing metabolic disruption and supporting hormone-sensitive pathways like those governed by insulin, cortisol, estrogen, and testosterone. Another major pillar of this new model is the emphasis on micronutrient density. Vitamins and minerals are not just supportive add-ons, they are catalysts for virtually every biochemical process that keeps cells functioning. Deficiencies, even if mild or subclinical, can impair mitochondrial function, reduce antioxidant capacity, and blunt the cellular stress responses needed to trigger autophagy and DNA repair. Nutrients such as vitamin D, B12, magnesium, selenium, zinc, and omega-3s are of particular importance in aging populations due to both increased needs and reduced absorption. Unfortunately, many of these nutrients are either absent from ultra-processed food or lost in restrictive diet patterns that overemphasize calorie control. A redefinition of healthy eating would instead spotlight whole, nutrient-dense foods, colorful vegetables, low-glycemic fruits, organ meats, oily fish, nuts, seeds, and fermented products, not simply for their caloric content, but for their biochemical value. These foods deliver essential cofactors for enzymes, support mitochondrial energy generation, and help regulate the immune system at a cellular level. What this all adds up to is a shift from a weight-centric to a function-centric model of nutrition, one that respects the dynamic needs of the aging body. It's not about being thin, it's about being metabolically flexible, inflammation-resistant, and able to repair and regenerate. This model embraces personalized nutrition, where age, sex, genetic risk, microbiome profile, and lifestyle factors determine optimal food choices. For one individual, that might mean low-carb Mediterranean eating with magnesium supplementation and extended overnight fasts. For another, it might involve plant-forward meals with timed protein intake and targeted micronutrients to offset a specific deficiency. The key is precision, not restriction, supporting the body's natural rhythms and repair cycles rather than overriding them with blanket dietary rules. In redefining healthy eating through the lens of cellular nutrition, We can begin to align dietary choices with the core biological processes that sustain longevity. This doesn't negate the importance of calorie balance or exercise, but it contextualizes them within a broader system of biochemical nourishment. When food is seen not just as fuel but as a regulator of stress response, gene expression, and tissue regeneration, nutrition becomes a far more powerful tool for aging well. It moves from being a means of avoiding disease to a method for actively building cellular youth from the inside out.